drops and there's big questions in there, and any issues you have, star it. And then when we do a one-on-one on Monday, we can go over any issues we have. And I can share your screen, you can share my screen with just one person in it. And I'll do an open-ended meeting so we don't have to do this. All right, does that sound fair?
Yeah. Good.
All right, let's start with this one right now. If we could just swing the camera over here, Brian, we'll just explain what we're looking for.
You're good.
All right, so calculate the currents and voltages at the loads if the following 3-wire circuit has an open in the neutral at point X, right there, right? So we're gonna calculate this one out. This looks simple, but it's actually very difficult, you guys. All right, the first thing we gotta do, you guys, is we've got to calculate out the resistance of load 1 and load 2 as it stands, as if the neutral was in there. You always got to remember that step because you can get lost if you want. So what we're going to do is we've got 115 volts there, 115 volts there, okay? We've got 3 amps here, so coming back this way, we've got 3 amps. Go up here, I've got 7 amps there. Going this way, I've got 7 amps, right? So the difference between 3 and 7 is 4 amps. And it's going to be going this way. It's important to write which way direction it's going because that depends whether or not it's a voltage rise or a voltage drop. Now I'm going to just drop off camera here for a second to get a pen. And I am not a blue one. I must have thrown them in the garbage. That's okay. Okay, so, no, here we go. I'm going to make a voltage loop in this little one right here, because we need the actual voltage over that load to determine its exact resistance. My voltage loop goes like this. From negative to positive. From negative to positive. Okay? So we can take 115, right? Well, oh, I gotta back up a little bit. I've got my voltage loop in there beautifully, but I forgot to do voltage drops. I'm going to drop here 14 volts over that line loss. I'm going to drop 4 volts over this line loss. I'm going to drop 6 volts over this line loss. Okay? So now I take 115 minus 14 minus 4 should equal 97 volts. Do we agree with that? I agree with that. So now let's do another voltage loop in here, going from negative to positive in that direction. We take 115. Now this goes against it. So 115 plus 4 minus 6 equals 113 volts on load 2. Okay? So once we have that information, that's beautiful, because now we can go back here and we can go 97 divided by 7 is going to give me 13.9 ohms. We can come here, 113 divided by 3 is going to give me 37.6 ohms. That's the only physical characteristics that's going to stay the same after we remove that neutral. Okay? So let's go like this. Let's get rid of that neutral wire. It's gone. These are no longer true. That's no longer true. That's not a true statement. That's not a true statement. Everything changes except the resistance and the applied voltage. Okay? So there's what the circuit looks now. We're going to do a big voltage loop from negative to positive, like this. And we're going to figure out what the voltage at the loads are. So now we're dealing with strictly 230 volts. We've lost our neutral in this circuit. So now we got to add up and get our total resistance. 2 plus 13.9 plus 37.6 plus 2 means a resistance total of, I got it written here just so I didn't screw up, 55.6 ohms. 55.6 ohms. If we divide that into 230 volts, we will get a new current, and the new current will be 4.14 amps with the 4 repeating, trucking that way. Okay? 4.14 amps multiplied by 2 ohms, that's the line resistance, is going to give me a voltage drop of 8.28 volts there. Same thing down here, 8.28 volts there. Okay? So now we come around here, we can use Ohm's law, and we can take 4.14 repeating and multiply it by 13.9, and we'll get a voltage over load 1. Voltage over load 1 should come in at 57.61 volts. We can use Gustav again, or Ohm's law, 4.414 come down here over 37. We should get a voltage of this of 156.11 volts. Okay? There's our answers. So if we come here, voltage over load 1 is 57.61. Voltage over load 2 is 156.11. Total current is 4.14 with the 4 repeating. The total line drop comes out to be 8.28 volts per line with a total of 16.56 volts total. Okay? So that's that one. Seems nice and easy because I do it in the right order, but that's a fairly tricky one. And the one that's similar to this on the test, I find guys get balled up on it. You just got to walk it back to resistance, know the voltage, get the current, walk that current back through that circuit. Okay? Any questions on this one? That only took me 2 minutes?
No, that's what you have left.
Oh, okay. Okay. All right, any questions on that one, guys? Are they unmuted?
No, they're unmuted, except for Dawson, he's got himself muted.
Okay. Probably wants to fart. Okay. All right, guys. We'll shut this down. Any questions about what I want to do Monday?